so we are going to learn how to look at the periodic table and figure out how many protons, neutrons, electrons are in these atoms, and also what their mass number and atomic number is. So reviewing really quick, protons and neutrons make up the majority of the mass of an atom, okay? So protons and neutrons. Now electrons are much smaller than protons and neutrons, so their mass is pretty much zero, okay? It's almost zero. I can't say it's exactly zero atomic mass units because it has to be made of something because it does have some mass, all right? We know protons, neutrons, and electrons also are made up of smaller particles called quarks. So there is some mass to an electron, but it's just much smaller than protons and neutrons. So when we're referring to protons and neutrons, we're going to say that the protons and neutrons have the most mass of the atom. They each have one atomic mass unit, and they are going to contribute to this mass number or the atomic mass. Okay, so if we are looking at the atomic number 26, the atomic number, the number of protons, and the number of electrons are all going to be the same. So I'm just going to put a little dot or something here. So protons, atomic number, and electrons are going to be the same. All right, so if the atomic number is 26, our protons are also going to be 26. And so are the electrons. So atomic number, protons, and electrons are going to be the same because right now the only atoms we are dealing with are neutral atoms. So that means protons and electrons are equal. Now, in order to find the mass number of the element iron, we are going to look at the two particles that have the most mass, which are the protons and neutrons. So in order to get the mass number, you're going to add your protons plus your neutrons to get that mass number. So 26 plus 30 is going to give us 56. Now, if you were to refer to the periodic table and look up iron, which is right here, you notice at the bottom the average atomic mass is 55.8. If you were to round that, it would go right up to 56, which is what we found for our mass number, okay? So on the periodic table, they're doing the average of all the masses of all the elements of iron, the isotopes of iron. And so it's typically very similar to that mass number, which is the protons plus the neutrons. Now, again, if you want to find iron on the periodic table, you're going to look up atomic number 26. So if we find number 26, notice here at the top, that's always going to be your whole number. Now, some periodic tables will actually have that atomic number below the iron instead of above. So just look for the whole number because atomic numbers will always be a whole number. So atomic number of iron is 26. Notice that the abbreviation is capital F, lowercase e, and it has to be capital and a lowercase. That means it is one element. If they were both capital, it would be two separate elements, okay? So it has to be capital and lowercase when you're typing these in. All right, so let's look at sulfur. Its atomic number is 16. That means the protons and the electrons are also going to be 16. We're going to look it up on the periodic table by its atomic number. So sulfur is number 16. So it's going to be right here. So sulfur is number 16. Its abbreviation is capital S. And again, that has to be a capital. Oops. Now we're going to find the number of neutrons in this particular element of sulfur. And so to find the number of neutrons, you're going to subtract your atomic number and your mass number. Because remember, atomic number is also the number of protons. Okay? So if there are 16 protons already, but the mass is 32, that means the neutrons are the rest of that mass. So to find what the rest of it would be is you'd say 32 minus 16, which gives us 16. So our neutrons are going to be 16. And it also tells you at the top of the page here, atomic mass minus your atomic number is going to be your number of neutrons. You're never going to have a negative number for the number of neutrons. The atom's either going to have neutrons or it won't, okay? You're not going to have negatives. All right, carbon, abbreviated capital C, has an atomic number of 6. That means the protons and the electrons are also 6. The mass number, again, is going to be your protons plus your neutrons, so 6 plus 6, which gives us 12. If you want to check that, you go over to your periodic table, find carbon. Your average atomic mass is 12.011, so if we were to round that, it would go to 12. Okay, fluorine, it has number of protons are 9, but again, protons, atomic number, and electrons are the same. So that means atomic number and electrons are also going to be 9. Find it on the periodic table by its atomic number. It's right here. Fluorine is capital F. So I'm going to type in capital F. Now to find the number of neutrons, we're going to subtract our atomic number and our mass number. So 19 minus 9 is going to give us 10. So there's going to be 10 neutrons. Okay, calcium has an atomic number of 20, so it's going to have 20 protons. It's already got the electrons there, it's 20. Got to find the number of neutrons, so we're going to subtract our atomic number and mass number. So 40 minus 20 is going to give us 20. Okay, now we're going to look at how we would actually draw these atom models. So we are going to draw using the Bohr atomic model. The Bohr atomic model says that the electrons are basically stuck in these orbits or these shells, as you can see here. It's basically stuck in those shells and they don't move around. Okay, they're kind of like planets that orbit around the sun. They stay in that particular path and they don't go anywhere. Okay, the rule says that the first atomic shell or energy shell holds 2 electrons maximum. Okay. Once the first shell is full, then you can move on to adding electrons in the second shell, and it will hold a maximum of 8 electrons. And then once the second shell is full, then you can move on, and your third shell is going to hold 18 electrons. Now, these are numbers that you have to memorize, okay? 2, 8, 18. This particular atom is lithium. So I'm going to go back to my periodic table here. Let's find lithium. Its atomic number is 3. So that means we're going to have 3 protons, 3 electrons. So I'm going to put my protons here where the nucleus would be. So it'll be 3. I'm also going to find my number of neutrons since we've been doing that. So if we go back, let's see, lithium has an atomic mass of 6.94. So we're going to round that to 7. So 7 minus 3 is going to be 4. So number of neutrons is going to be 4. Now we're looking at the number of electrons here. So if the first shell will hold 2 electrons, and we have a total of 3 because protons and electrons are the same, we're going to draw 2 electrons in our first shell. This is our first energy shell. It's the one that's closest to the nucleus. We're also going to kind of spread them out because they are both negatives and like charges repel each other. So we've got 2 in the first shell. That leaves us with 1 electron, and it's going to go in the second shell. So in this case, lithium does not need a third shell, okay? And also the second shell will hold up to 8, and lithium only has 1. So what that means for lithium is that it will combine with another atom on the periodic table to make what we call a compound. That means they will chemically combine. So you can look at the number of electrons in the outermost shell to see if it will chemically combine with something else. If it is not full, it will chemically combine. Since this one holds 8 and we only have 1, then it's safe to say that lithium will chemically combine with other elements on the periodic table.